mostly industry, but they are used in construction, in automotive, logistics, aviation, energy, health, you name it. And they are starting to be used in finance, in knowledge management, in education, and more. They are used in this vertical sector for design, for maintenance of the product, of the service, for tuning performances during the lifetime. They are used for safety, to check what is going on and proactively take action. And they are used as a way to increase the customer experience. In the image on the side, again from Bosch, you see that there are several areas that are supporting the digital twin. You have at the core the digital twin management with the API that allows the digital twin to interact with other entities in the cyberspace. You have the state management, the orchestration of several digital twins. You can regulate, control, and so on. You can use this kind of thing to support modeling, simulation, to understand what is going on, the semantics, to accrue historical data, to perform analytics, and so on. And all of this is embedded in the wider environment of software provisioning, device gateway management, and device access communication. So let's go to focus on industry, the digital transformation of industry. What is digital transformation? As I mentioned in the previous seminar, basically is a shift from the economy of scarcity to the economy of abundance. And this happens because we have atoms, we have physical stuff, and this physical stuff is scarce by definition. In order to duplicate something, you need new resources, and it costs money, and it costs time, it takes time. By using sensor, you can create a mirror image, you can create a digital twin of that thing. And once you have bits, you are into a completely different dimension because bits are abundant. You can duplicate bits basically at no cost. You can access bits wherever they are. Distance is no longer an issue. So you're entering the stage, the era of abundance. And clearly in this era of abundance, transaction cost, the cost it takes to do things is much lower. And this is why industry, as many other sectors, are trying to move as much as they can of their processes and their activity to the cyberspace to decrease cost, to become more efficient. And then can use this cyberspace using virtual reality that allows them to look inside the cyberspace. In Turin, we have developed a center for industry where basically industry can go and test their product. And within this center, there's what we call the cave. And the cave is a place for virtual reality that is completely empty, but you wear your goggle and you go there and you can see an engine, you can tweak the engine, you can work on it and so on, all in the virtual space. And this information, this data may reside everywhere. Actually, we have now a number of laboratories that are connected to this place in Turin. And the other labs are physical labs. And they actually contain physical engines and physical stuff. So what you do in this lab in Turin, you can access through virtual reality and mediated by digital twins, equipment of very many different types. And we are asking industry that are participating in the lab to provide the digital twin of their equipment, of their labs, so that they can be seen and manipulated from the cave, from the digital cave. Once you have a product, and you can still have the possibility of mixing together the cyberspace and the physical product using augmented reality. This allows you to look inside the product, as an example, by seeing what's going on inside, because you have the digital twin simulating what is going on inside, and using AR, you can see inside the physical engine. Now, this approach is affecting everything. It's affecting, of course, products, but is affecting processes, and most importantly, is affecting business model. Now you see that this goes across the whole values, the whole life cycle. And we see that it goes for the design phase. We are using it for enabling co-design, meaning that different industry can work at the same time on the same project. It affects the supply chain because they can use the digital twin to synchronize the various stages in the supply chain. And the digital twin can actually orchestrate the supply chain, directing trucks and warehouses and so on to perform. They are used within the manufacturing process. You see in the picture there, the digital manufacturing. You're moving from the digital model into the physical implementation. Sometimes you're using 3D printers, additive manufacturing, and so on. And then you keep on using your digital twin to follow the operation of the product and its maintenance. And you can even use, this would be stage 4 and 5, you can even use your digital twin to build up virtual components by assembling several digital twins. Now, when you're living in the space of data, data is actually a value, okay? It can have a value, but actually we said that data are so abundant, there's so much of data that it's difficult to place a value on data. And if you think about it, you go on internet and you get almost everything for free. So data don't have a value. How do we compensate for this intrinsic low value of accessing data, manipulating data with the potential value that data can have? Well, it all depends on what you're doing with those data. If you're looking just at what happens, so you have a digital twin that is acquiring information, you perform descriptive analytics, and you understand what happens. But then you can do some simulation and try to understand why something happened. This is diagnostic analytics. And then you enter into the space where really you are getting into value. And the question is, what is going to happen if I'm not doing anything, okay? Will we have a problem or something like that? This is called predictive analytics. And then, of course, the highest value is when you can do something about the situation that has been forming so that you make sure that it only happens what you want to happen. This is what is called prescriptive analytics. And this, of course, requires the capability to act on the physical space. Now, the digital transformation is going on everywhere. You see on this chart various dots with the state countries and where they are with respect to the digital evolution stage on the y-axis and on digital evolution momentum on the x-axis. Actually, what is most important is the derivative, which is the momentum. Unfortunately, you see the Pakistan, that's the circle, the blue circle, is not well positioned in this thing. So there's a lot of things that needs to be done. Actually, I know of a few textile industries in Pakistan that are operating using digital twins. But unfortunately, these digital twins are just providing information for operation and maintenance to companies that are in Italy. So you're not using in Pakistan digital twin for the sake of managing the company, but actually these are used by foreign companies providing services for maintenance and operation that are residing in different countries. I guess that there's a great potential to grow. And actually, one of the things that can be done and should be done is to have universities such as yours and students such as you to join the IEEE to develop software for digital twins. And once you get the handle of that, then you can start applying that software to your local environment, to your municipalities, to government, to industry, to local industries, and so on. So you can use IEEE and the work we are doing in this area on digital twins as a sort of school. And we are more than willing to interact with professors to set up a course or a plan for participating in our activities. As a matter of fact, as I was mentioning, we are very active at the IEEE on cognitive digital twins. That are those things that are being used in robots, in advanced robots, but also they will be used to bridge the human intelligence with machine, with artificial intelligence. And we have an initiative, it's called Knowledge as a Service, that is an open initiative, which means that if you want to do a thesis at university in this area, if you want to develop software in this area and so on, you can join these initiatives. We can even provide you with some little money to work on that. And we have a digital transformation course available through the IEEE that you can use to learn much more and then start doing things. What you see on the right-hand side is just a screenshot of a very little part of the IEEE ontology, the set of knowledge states. We have coded some 14,000 knowledge nuggets in this space, and you can browse them and discover what is new, what is old, what the story of that thing, what courses are on this thing, what kind of articles are connected, what conferences are coming up, and so on. So the industry 4.0, which is a European initiative, in the US is called Digital Industry, in Japan is called Society 5.0. And the reason why they are calling it Society 5.0 is because the Industry 4.0 is going to change the way people are working and the societal relationship among people, among companies, and so on. So in Japan, they are putting much more emphasis on the societal aspects, but it's the same thing. So the point of Industry 4.0 is to take the industry to the cyberspace. And in order to do that, they have to use digital twins to connect the cyber with the physical space. They need to rethink industry processes. It doesn't make any sense to move things into cyberspace and then operate in the cyberspace in the same way you would operate in the physical space. So you need to rethink your processes. And as an example, Siemens and SAP, you know these are worldwide companies, okay? SAP is focusing on enterprise resource management, and Siemens is providing the tools for the factories to work. Well, these two companies have joined forces to create a seamless implementation of digital twins so that they can cover the broad spectrum from the tool to the knowledge, okay, to the resource, enterprise resources. So it's a very, very big initiative, and it's going to have a very profound effect. So let's go now to the real focus of my talk, which is the adoption and use of digital twin in industry. A part of these slides have been taken from an event that took place just last week. So I use these because it's the very most recent thing. And it was an event on the use of digital twin in industry. There were a lot of industry present, and there was a deep discussion and in-depth discussion on what are the challenges, how can be used, and so on. The first point that emerged was the fact that the digital transformation and digital twin are two faces of the same coin, in a way. One enables the other, one needs the other. And the first consideration was the fact that this transformation and the adoption of digital twin in the industry is actually a consequence of a market pool. Is the market that, because of their requirements and what they want to have as products, as final product, is pushing companies to the digital technologies, because market is changing rapidly in their requirements, so they need to have very flexible products. But having very flexible products also means that a good portion of the products should be done in software, because it is much more difficult to change hardware. And once you have software, then you can have a part of this software residing in the cloud, and you can basically delocalize the operation of the product. And it gets much easier to change the products also during its lifetime. So this is really a market requirement that is putting pressure and that leads to digital transformation and adoption of digital twins. Also, the more you're using software and the less environmental impact you're going to have. And this is coming to the fore as a very, very important issue in many countries. And after the COVID, during the COVID recovery, we have seen a lot of money being poured in, And one of the conditions to get the money was to use it in such a way that we are decreasing the environmental impact of industry. So this is another force that is pushing industry to adopt digital twin and to go into digital transformation. Okay. Industry, when you're talking about industry, we imagine something that generates a product. And that's, of course, is completely correct. However, the real challenge for industry is not producing a product, is the production itself. There's no product without production. And the cost of the product, in the end, depends on the production. When you want to go into mass market, you want to have volumes of production, then it's absolutely necessary to control the supply chain and the delivery chain. And this places you as an industry in very tough water, because how can you control suppliers? How can you control the delivery? Okay, you are just focusing on the product, on producing it. So really what you need to have is some way of synchronizing, monitoring the whole value chain. And this is an area where digital twin can really help. And this is why industry is adopting also digital twin and forcing all the component of the value chain to adopt it. If you're looking at Siemens, they have MindSphere, and MindSphere has been designed to take into account the whole value chain. So you see in this image on the side that we have on the lower part, the physical, the real world, so-called real world, and on the upper side, the digital world. What you're trying to do is to move both products and production as much as possible into the digital world. I listened to a presentation to an interview of Elon Musk just 2 days ago, and he recalled that they were facing at Tesla a big difficulty in 2008 and 2009. And again, they were struck by big difficulties in 2019. All of these is because it's so difficult to go into mass production. Whenever you want to move from a prototype to a real product and go into mass production, is really difficult, very complex. And this is where actually digital twin and digital twin instances can really help. Now, focusing on the production side, you can use digital twin for mirroring the factory in the cyberspace. And by doing that, you can access digital enterprise services. So rather than having to deploy services in the real factory, you can do a lot of things in the cyberspace using what is called digital enterprise services. And there are many companies that are now working in this space. But in order to tap into these, you need to go into the cyberspace. And the other thing is you can use digital twins to monitor what is going on through the cyberspace. And here you can use virtual reality, augmented reality, so that your people working in the industry, by using this kind of devices, can actually walk into the cyberspace. You're getting plenty of data. Factories today use IoT, they use private 5G or 4G or Wi-Fi 6, and they harvest tons of data. Now, what you want to do is to use this data through data analytics, through artificial intelligence, to derive information and knowledge, understanding. And to do that, you are capturing this kind of data and you are encapsulating them into digital twin. So actually, digital twin is transforming what is data into meaning, okay, into semantics. And you can get feedback also from the delivery chain, the way that people are using your product. And you can input this kind of information to the production so that the next release of products can be done slightly different to meet what is the real usage of the product in the physical space. As I mentioned, you can use augmented reality on the shop floor. This will bring all these data analytics that you are developing and creating in the cyberspace to the shop floor. You can also use digital threads as records. Okay, so you go into a digital twin and you see what happened to that particular instance or product. And the other way around as well. You can use the records that exist today in a company, in a factory, to create a digital thread and therefore a digital twin. So whenever you're looking at an industry, you can be sure that they have plenty of paper that is recording what has happened over the time. And if you digitalize that paper, if you go into the files in the computer, you have all the records and so on, you can cluster them and provide an ontology and then harmonize them into digital twin. So this is also the starting point for an industry to move into digital transformation and use of digital twins. You can use the digital thread for data analytics, for performing artificial intelligence meaning, derivation, and you can also use a digital thread for machine learning. You learn from the story. You understand what happened, what's going on. Now, you got to use digital thread both for product and for the factory. And this is very, very important. By using digital thread, you can understand that certain tools need to be maintained after a certain number of cycles, because you learn that after a certain number of cycles, it gets problem. But it's more than that, because tools are being used in many different ways. And therefore, it changes the wearing of a tool or the probability of breaking down, depending on what actually the tool has been processing over time. And so this requires data analytics. And if you have a thread, a digital thread, you can do this kind of thing. You can use a digital twin as product design. You can take a digital twin that's already existing of one of your products, and then you change it for creating a different product, slightly different product. You create a digital model of that one using mechanical design, and you can adopt incremental design using digital thread, which means that basically you start with a piece, then you see what's happening with that, you do simulation, and then you change it a little bit and so on. You are incrementing the thread, and as you do that, you're learning what works and what doesn't work. You can do product optimization by performing simulation on digital twin. Even before implementing, creating the product, you do simulation on digital twin. And you can adopt what is called generative design in industry. Basically, you see it on the lower part, on the second pictures, where you have this kind of blue things. Well, they represent the flow of gases into waste pipes of an engine. And what happened is that they started with the reference you see in the beginning, and through simulation, they worked out the best, the optimized way of shaping the pipes to decrease at maximum the drag on the flow, so that it doesn't overcharge and overheat the engine. And this is a way of doing. This is called generative design through simulation. You go step by step. In the upper figure, you see several kinds of simulation of what may go on into an engine. And based on that, you design the engine. You can also, and this is very important, simulate production processes, because you usually already have a factory. And what you need to understand is, okay, my factory works pretty well now, but what if I have to produce a new product? How will my tools work with that? What should I change? What kind of changes should I implement because of this kind of things? So you're using simulation on production processes as well. Then you've got to design not the product, but the production. This is very important. Most of the time when we're talking about industry, we think only about the product, but that's not the major challenge in industry. The major challenge is how to produce the product. And so you need to design the production process. You need to look into the plant life cycle management. You need to understand the physics of the various equipment, how they interact with one another, and you do that through simulation. You need to integrate the various processes, and you do the planning for that. You need to optimize the plant as a whole and the assembly line. And you need to understand the virtual commissioning, which means basically, how do I work with the supply chain? How do I work with the delivery chain? And so on. This is all being done by using digital thread and digital twins. Then once you have this plan, you need to plan for the extension of the factory. Probably the space that you have is not sufficient. You need to expand it. And then you can create the design of the new area. And you can do this using 3D design that is becomes part of the digital twin of your factory. And then you need to go into the various pieces, the components, the various tools that you have. Probably some of these tools will have to be acquired from scratch. Other may need to be adapted. And so the tool adaptation design is also an important part that needs to be validated and to optimize the equipment. And this is very important because it's costly, this kind of process. You need to understand, should I buy something new? Should I adapt something that I have? But how does it work with the product? And so what you're doing, basically, you're going to have a simulation where the digital twin of the tool and the digital twin of the product that does not exist yet are placed in simulation once against the other. And you find out what's going on and how it works. Then you need to optimize the plan. So where do I place the different tools to make the whole system very effective? And you will have to deploy probably AGV, automatic vehicles, autonomous vehicles, robots that are moving stuff from one part to another. And you need to find the best way of moving these kind of things around. This can be done through simulation and should be done and validated before implementing the changes. Again, this is a space for using digital twin. Once you have implemented this kind of thing, you might run into a situation where you need to change something. And this is called a closed loop manufacturing, okay? You are doing something and then you receive a feedback saying that, oh, I need to change something, but you have a closed loop, okay? It's all being defined previously. So here is where it is so important to run as much as you can, at least in the cyberspace, because it's much easier to change stuff in the cyberspace. It leads to flexible execution, flexible manufacturing, okay? And so this is something that is being done and simulated at the DT level. And then you've got to look at the whole product lifecycle management, what is called PLM. And you've got already plenty of PLM platforms. They are now using digital twins for this kind of thing. They go into a database with the bill of materials. They know what kind of materials, they know what kind of processes are involved, and they turn this kind of thing into the shop floor instruction to operation, for the execution. The other thing is that quite often your factory is producing different products, and these products are using sometimes the same tools. And so you need to understand when to use and what to use and organize for the maximum yield of your production. You can also receive feedback from the distribution chain saying, I need more of these, I need less of that. And so you need to create a dynamic production scheduling. You see the image there on the right-hand side. This can also be done and simulated through digital twins. Now, let me give you some concrete example of use. First one is Siemens. I use this as the first one because they are the one producing the tools that are being used by many, many industries worldwide. And they have this MindSphere platform that I already mentioned. They can deploy together with their tools, the private 5G. They have a license for deploying this kind of thing. So they come to your place, they deploy the tools, they set up the connectivity space in 5G, private 5G or Wi-Fi 6, and they are harvesting all the data from the various IoT from the tools, bringing the data into the MindSphere. And MindSphere is supporting all the software to design the product, the virtual product, as you see in the image on the right-hand side, creating the digital twin of the virtual product. Then they're using the digital twin for the production, first in the virtual production, and then in the real production. Remember how important it is to move as much as possible the production into the cyberspace and only produce at the very last stage. And then MindSphere can assist you into the feedback, receiving feedback from the real product, how it's being used, okay, what are the problems, and also to support delivery of services to the end customer. Boeing is an example, one of the first that have been used at digitalization of the whole supply chain. And the reason is because an airplane like the 777 has some 5-6 million components. And all these components are basically assembled by Boeing. Boeing is not really developing anything. They are an assembly line. And they need to make sure that all the various suppliers are supplying the right component that will fit exactly with the components provided by our supplier. So starting with the 777, they created a fully automated digital supply chain. And they are using digital twin for controlling this kind of thing. It's an amazing thing. I've been spending some time at the Boeing factory in Seattle, at the Boeing field, and it's impressive to see this kind of thing. They go into details, the final bolt and nut, okay? Everything is digitalized because everything is tested before being acquired and before being assembled in the digital space. So they know exactly that that kind of bolt goes perfectly into that nut and so on. General Electric has been probably the first company to formally use digital twin and to use them as an integral part of their product. For every component, for every turbine that they are developing, they have a digital twin. And this digital twin ends up in their cloud in California so that they keep receiving information, data from the physical engine, for the physical turbine, and they monitor what's going on. And they are able to tell back to the physical turbine, hey, you should change something because this is not working properly, okay? And they have managed to optimize the workings of engines, the workings of power mills, power plants for generating electricity in various forms. And now they are considering, they've started to use digital twin in the healthcare space. They've started doing that 2 years ago, creating digital twin of hospitals, of equipment, medical equipment, to orchestrate the functioning of a hospital. And now they are moving through their digital health division into the space of personal digital twin, trying to create a digital twin of people, of patients, and to help in proactive health. Tesla, you know of Tesla, of course, the electric car manufacturer, the Elon Musk company, and they have been using digital twin from the very beginning. Every Tesla car has a digital twin instance. And what happened is that every night, Tesla cars are reporting back to the cloud of Tesla all the data that they generated through the day. And these are gigabytes of data. Eventually, every night, Tesla is receiving the equivalent of 1.6 million miles driven by their cars. And they are using the digital thread to find out if there are problems and to make better products. And to make better products in real time. Because since Tesla is working with a lot of software, what they do is that once in a while, they are changing the software to upgrade the safety and the functioning of each of their cars without the driver being aware of that, what is going on. And actually, I've got an example that 3 years ago, through artificial intelligence, they were able to find out that a certain number of cars, of Tesla cars, were having a suspicious vibration in one of the suspension. And using the digital thread, they were able to track back the reason for this vibration to the fact that those particular cars were produced, assembled at a time where there was a maintenance of the assembly line, and the two robots that were actually mounting the suspension, one on the left and the other one on the right, were tightening the screws at a different strength. So that created over times, after several thousand miles, an imbalance between the two suspension, and that generated this kind of vibration. It was so tiny that actually drivers didn't detect the vibration, but the sensors did. And so what the Tesla engineers did was to send out a warning message to all their workshop around the world saying, when a Tesla comes back to you for the normal maintenance check, if it has this production number, then you must tighten through the bolts in this suspension. So that's an example how to use the digital thread to fix problems. Mevea is a Finnish company, and they are great in the use of digital twin as a competitive advantage. They are working in a very packed market, the one of machine that are used for construction, for road construction, building construction, this kind of thing, where you have the guys like Hyundai, Caterpillar, and this kind of thing. And their business proposition is that if you find something that is good for you from Caterpillar, just buy it. But if you cannot find something that is really good for you, what you want, then come to us. And they are building customized machine for very specific construction or hard job, heavy jobs. What they do, they are understanding what your problem is. They are sending their people, their engineers with drones on the place where you're going to use the machine, and they take photogrammetry with drones. And then they come back and develop the digital twin of the environment where you will be using the machine, and they develop the digital twin of the machine that you have asked. And then they call on you, and you see this is a person that is actually going on the Mevea premises, is using the machine that is actually a digital twin of the machine in the space that is actually the digital twin of the space where he will be using that. And by doing that, he just makes some fine tuning, make sure that everything works. And once everything works, then Mevea build the actual machine. And when the machine is delivered, the person is already trained on the machine because he has been trained on the digital twin of the machine, on the digital twin of the place where he will be using the machine. More than that, the machine, the physical machine, will report back information data to the Mevea company, and they will check and monitor what's going on and finally tune all things. Okay, we're coming to the end. Arup is a different kind of industry. This is an industry that is moving in the construction area, and they're using digital twin to monitor their buildings. They develop digital twins at the design stage, but then they're using the digital twins as a way to monitor how effective is the building, what kind of vibration it has, how effective the insulation of the building is, and so on. And they are learning from buildings that are spread around in 158 countries. So they have an amazing knowledge base where they can derive information. Finally, all this use of digital twins in industry is basically about using the cyberspace. And this company, Dallara, I don't know whether you know them, but if you Google for them, you'll find out. Dallara is a company that is producing chassis of cars, of sport cars, for Lamborghini, for Ferrari, and all this kind of company, for General Motors and so on. The interesting thing is that what they mean with producing is that they are developing the chassis in the cyberspace. They are not producing the actual thing. They are producing the model. They are simulating it. They are checking it. And their people are not engineers. They are mathematicians. Because what they do, they develop models and the digital twin. And once they are fine with that model, then they hand over the digital twin to the production. It may be Ferrari, it may be Lamborghini, whatever, and they are building the actual chassis. So you see, that's a whole new world that can operate, a whole new industry that is actually living in the cyberspace. Okay, with that, I thank you. And you can see again my address here, so you can get in touch with me. Now, if you have some question, we do have a few more minutes. The floor is open. Okay, I see one question. What is a digital twin in IoT, and why is it important to IoT? Well, basically, IoT can live with a digital twin as their counterpart. The idea is that IoT is a sensor, maybe a very complex sensor, and then it produces data. This data can be processed by the digital twin in the cyberspace. So basically, you have the sensor connected to the digital twin, and you can use the digital twin in the cyberspace. So there's a lot of work in IoT connected to the digital twin. And if you have platforms like Fireware, like MindSphere, like GE platform, and so on, you see that they are not selling IoT. They are selling the package, digital twin and IoT all together. So the difference between IoT and digital twin is the fact that the IoT is the physical stuff, the sensor that you have deployed somewhere, and the digital twin is mirroring the IoT by shadowing the status, by accruing its data. And whilst the IoT has no memory, basically, the digital twin has the digital thread. So it has the memory of what kind of sequence of data were generated by the IoT. The two go hand in hand. I see that Jawad Hamed has raised an hand. You want to? Okay, probably you may want to write down your question as I go along and answer the other. Is 3D required to create a digital twin? No. 3D is just a sort of representation that you may use to render the data space of a digital twin of an engine, as an example. If you want to show that digital twin as augmented reality on the engine, but you don't need that. What industry use digital twins? Well, I guess I hope at least to have made it clear. More and more industries are using them. I mentioned in my example, Arup, Siemens, Boeing, Tesla, General Electrics, but I cannot think of a big company that's not using digital twins. Ericsson in the communication space is using digital twin. CFA is using digital twin. Ford company is using digital twin. So basically everybody's using digital twin. Textile industry is using that, as I mentioned. SCADA, SCADA. I mean, you mean with SCADA the Swedish company? There's a Swedish company that I know, and they're using, or you need the software. Okay, if you mean the software for data acquisition and so on, well, that's just another platform, and you can use SCADA as the acquisition part to feed a digital twin. I don't know whether they provide direct support for creating a digital twin, but surely is an aggregation platform. So yes, it can be used for digital twins.
Okay, Jawad Ahmed, if you have any question, you can mute your mic and ask.
I see Dr. Mahmoud saying, can we say it's a mechanism to bring the real world into digital environment? Yes, absolutely. That's the point. Okay, and by moving to the cyberspace, you are more effective. You have lower cost. You're quicker, and so this is why I was mentioned at the very beginning that digital twin and digital transformation, they go hand in hand. Okay, Here I see a very interesting question from Sanaga Kazi. What do you think that is digital twin good for cybersecurity field as well? Well, I am involved. I've been involved with the Poste Italiane. Poste Italiane is one of the main player in banking, in mailing, in packaging, delivery, and logistics, and so on. And they are also the leader in cybersecurity in this area in Europe. And they are using digital twin at their control center. So basically, what they do, they are trying to understand what is going on in the network, whether there are phishing attempts and all this kind of thing. And they have a very impressive wall of displays. Behind that wall, there are all these software packages that are basically digital twin that are trying to understand what is going on. So yes, digital twin are also being used in cybersecurity. Okay, the other aspect asked from Hafia is that cyber threats are everywhere. How can we secure our digital twin system? Usually, the platform that I was mentioning before, like a MindSphere, like GE platform, like Fireware, and so on, they have a layer that is supposed to protect digital twin, to authenticate digital twin. There's a way of blockchaining digital twins and the communication between the environment and the digital twin to make sure that you are not getting attacks, false data, and this kind of thing. But you know that the whole area of cybersecurity is a fight and catch. You know, it's not in that we don't have a silver bullet. We set up protection. We can set up barriers to make it more difficult, but then we'll discover that somebody has found a way to break through the barrier, and therefore we have to patch it and to bring up a better one, and so on. And it will be a never-ending story. I'm not confident that we will come to a point where we say, okay, no more cyber threat. Now everything is secure. So it will be a continuous thing. And actually, the use of the digital twin in the area, as I was mentioning by Poste Italiane, of cybersecurity is exactly for that, trying to monitoring if there might be a threat. They're not used to stop, to make sure that there's no threat, but actually to see whether there's a threat, and then you can jump in and try to fix it, to stop it. Okay, I think that we have reached the end of our discussion today. Thanks a lot for having me with you. If you have other questions, you know my email. You can get in touch with me. If you have something more specific you want to discuss one-on-one, we can set up a call with you. If you want to work in the IEEE area, if there's a professor among you that would like to work together with IEEE and set up thesis to work in this area, you're more than welcome. Just get in touch with me. Thanks a lot.
Thank you, sir. Give me your time for this webinar. Thank you very much, sir.
Thank you.
Okay, bye.
Thank you, sir. Thank you, sir, for giving your precious time for us.
My pleasure.